We're going to begin a new chapter on solving quadratics. Let's first define what a quadratic is. This is a quadratic equation that has coefficients a, b, and c, which a, b, and c are all numbers. So the degree of a quadratic is 2, which means that the highest exponent is 2. So this is a quadratic because it has an x squared. In this case, you cannot have a be 0. You can't have a coefficient of x squared being 0, because then what you have is bx plus c equals 0, which is a linear equation. So a quadratic equation is anything with the highest exponent of 2. So now in this case, b could be 0 and c could be 0. So examples of quadratics would be 2x squared plus 3 equals 0, x squared plus 5x equals 0, or 3x squared minus 5x minus 3 equals 0. So these are all examples of quadratics because they all have x squared. Notice that this has a missing value of b, this has a missing value of c, and this has no missing value. So these are all three ways that a quadratic can look. All three of these examples are quadratics in standard form. Standard form, we've learned before, means the exponents are decreasing. And it's equal to 0. So regardless of your method on how to solve a quadratic, in order to solve a quadratic, it must be in standard form. So the exponents must be decreasing, and the entire thing must be equal to 0. So now what we're going to learn today is how to solve quadratics using a quadratic formula. Let's just define a couple of things first before we do that. A solution of a quadratic equation. Let's say this is our quadratic equation, and we solve, and we get x equals 2 and x equals 5. These are called the roots of a quadratic. The roots of a quadratic are where the graph crosses the x-axis. So when you solve, whether you're solving by factoring or solving by the quadratic formula, what you're searching for is the roots of a quadratic, and visually, that's where the graph crosses the x-axis. So let's go through some examples on how to solve with the quadratic formula. The quadratic formula is an equation that helps you solve quadratic equations. The quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So let's just look at this equation real quick and just identify some important aspects of it. This plus minus means you'll get two solutions. You're adding and subtracting. It's all over 2a. Negative b plus or minus the square root of b squared minus 4ac is the numerator of 2a. So 2a is the denominator of this whole fraction. Make sure you're including this negative b in the numerator of 2a. So now, this means we're plugging in the coefficients a, b, c into this formula, and then we're just cleaning it up. So an example, let's solve for x in x times x minus 3 equals 18. Step 1, standard form. So that means we have to distribute the x and subtract 18. So we get x squared minus 3x minus 18 equals 0. So now we're in standard form. Step 2, identify a, b, and c. So in this case, we have a equals 1, b equals negative 3, and c equals negative 18. Step 3, let's write the formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. And now we'll input a, b, and c wherever we see it in the formula. Think of this as the opposite sign of b. So negative 3 is positive 3. So we'll have x equals 3 plus or minus, again, negative b. b was negative 3. The opposite of 3 is 3. b squared, negative 3 squared, minus 4 times a. a was 1. Times c. c is negative 18. All over 2 times 1. So step 4 would be plug into formula. And now we just have to clean it up. X equals 3 plus or minus square root of 9. Negative 4 times negative 18 is, let's see, 40 plus 32, which is 72. X equals 3 plus or minus the square root of 81 over 2. So this would all be simplify radical. And then we could express 81 as the square root of 81 is 9. So we could say x equals 3 plus 9 over 2. X equals 3 minus 9 over 2. Notice how I separated the plus or minus. It made it two different solutions, 3 plus 9 and 3 minus 9. So now 3 plus 9 is 12. 12 divided by 2 is 6. 3 minus 9 is negative 6. And negative 6 divided by 2, x equals negative 3. So now these are the roots, which means the graph of x squared minus 3x minus 18 crosses the x-axis at x equals positive 6 and x equals negative 3. Let's do another example. Let's solve for x in x squared minus 6 equals negative 4x. So let's get it into standard form. Let's add 4x to both sides. And now we have a quadratic equation which is in standard form. So in this case we have a equals 1, we have b equals 4, and c equals negative 6. We're only plugging numbers into the quadratic formula. We're not plugging x's into the quadratic formula. The point is to solve for x. So let's write the formula. And now we can easily plug into the formula because we've already listed the values of a, b, and c. Negative b would be negative 4 plus or minus b squared, which is negative 4 squared, minus 4 times a, which is 1, times c, which was negative 6, all over 2 times 1. Now we just have to clean up inside of the radical. So x equals negative 4 plus or minus the square root of negative 4 squared is 16. Negative 4 times negative 6 is positive 24. And 2 times 1 is 2. So we have x equals negative 4 plus and minus 16 plus 24 is 40 over 2. So now last example we had a perfect square. We had radical 81, which we were able to take the square root of, so we got integer solutions, or rational solutions I should say. We were able to take the square root of 81, so we got nice clean looking solutions. In this case, radical 40 is not a perfect square, so we'll just have to express this in simplest radical form. So a little side work, I can say radical 40 is radical 4 times 10, in which 4 is a perfect square. So we can express radical 40 as 2 radical 10. I was going to write 4 radical 10. 2 radical 10 over 2. And now I can divide both of these terms by 2, so let's simplify. X equals negative 2 plus or minus radical 10. If I wanted to, I could express this as my first X solution is negative 2 plus radical 10, and my second solution is negative 2 minus radical 10, just to show that there are two different solutions, which is okay. Either one of any of these solutions would be the same as long as you're listing it as two different solutions. So I can list it like that or like that, either way. So there are two solutions because I'm adding and subtracting something, and I have irrational solutions because the inside of my radical, b squared minus 4ac, was not a perfect square.